is 9.2, adding polynomials. Look, we've done this and done this and done this. We've done this since pre-algebra. This is no big deal. All we're doing is adding like terms. But this is the polynomial chapter, and we got to make sure we're squared away with adding our polynomials. All right, remember, technically, to add like terms, you're supposed to add their coefficients. So the A is a multiplier of the x, and the B is a multiplier of the x. So you're supposed to add them. And I'll tell you what, let's handle addition and subtraction at the same time. Let's put a minus sign underneath our plus. So it's two rules in one, right? I'm showing you two rules at once. So therefore, that'll be a plus or minus. If it were a plus between, it'd be a plus. If it were a minus between, it'd be a minus. And then, of course, there's that many of them, right? I want that to be black. That many of them, right? Now, whenever I give that rule, why do students miss the rule? Because what don't they include to cause them to miss the rule, Kaylin? They don't include the parentheses. So don't write this. But are these the same thing? Don't write this. Is that the same as that? No. And that's why you got to have the parentheses. Because 5 plus 3x isn't an 8x. You got to have the parentheses when you're showing the rule. So don't forget the parentheses. Now that I showed you that, not a one of you will forget the parentheses, right? Wrong. If I were a betting man, I would make some money. All right. Anyhow. So adding like terms. And look, honestly, if you're going to go by the rule, we'd use that parentheses. But we're way past that, right? We're just saying, hey, it's a positive 9 of them and a negative 15 of them. For a grand total of negative 6 of them, right? Again, adding like terms, we've done it forever and ever. Piece of cake, no sweat. So again, if I use the rule, I'd have to go parentheses 9 minus 15, close parentheses y cubed. But we just know there's 9 of them minus 15 of them. All right, so now what can give students a little bit of pause is when we use a parentheses to show the polynomial. So you can see we're adding two trinomials, agreed? But because it's addition, is either parentheses actually necessary? And the answer is no, because it's addition. So really none of the parentheses are needed. Just go around and add up the like terms. 3 of them and 7 of them, right? We're back to like first grade, 10 of them. And by the way, notice I'm going to go in order, right? Because I want to have the final answer in proper order, highest power descending. So now I'm going to do my x's to the first, a negative 5 of them. And that one gives you a grand total of what? Negative 6 of them, because again, we don't show the ones, but we all know there's a 1. And now we can finish with our numbers. 2 of them minus 15 of them is a negative 13. And that's it, right? Piece of cake. No sweat. Voila, we are there. Life is easy. Life is grand. Oh, no. We got to add 3 binomials. Oh, my. All right, go ahead and do that. I'm going to pause, give you a couple seconds. All right, hopefully you're done. Hey, if you're kind of one thing wondering, well, what do I put first? The x comes before y, and both x's are to the first power, so I'm not really sure what to do. You know, there are exceptions that make you have to think. I'm just going to do the one with the y's as well first. I wouldn't go against you if you wanted to put the y squared term in the back. But look, this is 3 of them and 11 of them, so there's definitely 14 of them, right? 14 of them. Negative 5 of them and a positive 2 of them is a negative 3 of them, but a negative 3 of them and a positive 8 of them is a positive 5 of them. So we have 5 x's, and what? All we got is the negative 11 tacked on to the end. And our 3 binomials added up to a trinomial, which is of what degree? What degree is our trinomial? Third. 1 plus 2 is 3. Remember, we don't write the ones. We don't write the ones. Any questions on that, anybody? Questions on that? I was just adding like terms. When it's addition, the parentheses really aren't even necessary. Oh, no. Subtraction. All right. So let me pause. Why don't you guys go ahead and do A. Everybody distributed that negative, right? Because the parentheses definitely matters when it's subtraction. So 5 of them minus 7 of them is a negative 2 of them. 1 of them minus 8 of them is a negative 7 of them. Negative 3 of them and a positive 4 of them is 1 of them. And I'm not, going to put the 1 there, right? Because I don't want people to snicker and laugh at me, right? So I'm not going to put the 1 there, of course. And positive 2 and a negative 9 is a negative 7. How many had negative 2x cubed minus 7x squared plus x minus 7? Okay. Hopefully you're not going to make that mistake again. We've done this before, folks. It's not like we haven't distributed when a negative has been in front of a parentheses before. We have done that ad nauseum. You know what that means, right? Until you're sick of it. How could you forget to distribute your negative? All right, so go ahead and do B. Redeem yourself. Do B. Be redeemed. All right, on 3, give me your answer. 1, 2, 3. All right, and I heard a negative 4x squared, right? Okay, let's throw one more in. You got to do one more. One more. How about this? Whoa, 2. No. Tell you what, let's go. Let me go left here. Let's do it over here. How about this one? 2x parentheses 3x minus 4 close parentheses minus 3 parentheses x squared minus 2x plus 4 close parentheses. All right, last one. Try that. All right, on 3, give me your solution. 1, 2, 3. How about 3x squared minus 2x minus 12? Anybody? Anybody? Nobody? Who got it right? Okay. And where did you make your mistake? So this has a problem with, and that's why I want to throw it in at the end, some multiplying with the distributing, right? And multiplying of exponents. So obviously 6x squared minus 8x. And I decided to line them up when I did the second one. So again, I could have done this horizontally and then added, but I decided to line them up. A negative 3x squared, a positive 6x, and a negative 12. And therefore, I had things lined up in columns to finish it off. You didn't have to do it that way. We'll talk about that later when we do multiplying binomials and polynomials. All right, any questions on that? Look, we've done this stuff. You should be good. We'll quit there, and you got the rest of the period. Good.